Okay, so the other common type of normal distribution problem are problems where they give you a proportion, they give you a percentage, and instead they're asking you the data point that corresponds to that. So it's the other way around. For these problems, we use the inverse normal distribution, or it's called INV norm on the calculator. INV norm was found in exactly the same place as normal CDF. You just go to that distribution menu. I think it's option 3. When you call this function in the calculator, it's going to ask you for 3 things. It's going to ask you for the area, the mean, and the standard deviation. The last 2 things are really easy. The first one actually requires that you know what you're doing. The area that inverse norm is referring to, and this is crucial, if you get only one thing out of this video, it's this. The area that INV norm is referring to is always the area to the left of the value that you're looking for. So if they give you a problem and they say like, oh, the top 20% of students, are selected for a special honor. Well, that's great. 20% of students are above some value x. If you're going to use INV norm, the area that you're referring to will always be the 0.8. It'll be the area that's to the left of that x value that you're trying to find. Okay? So just like I did in the previous video, I'm going to be going through the same 2 examples, the part B of them, from the first video in this sequence. So we'll take a look at those now. Okay, so again, the mass of toys being manufactured has a mean of 400. So again, we've got our bell curve here. We've got our mean of 400 in the middle. We've got our standard deviation of 15. They're saying the heaviest 10% of toys are rejected. So there's some region up here that's rejected, and we know that area is 0.1. Okay, but that means that the ones that are on the other side of that, there's an area of 0.9 over here. And that's the area that you're going to want to give to INV norm. So when we bring up INV norm, it asks for area, it asks for mean, and it asks for standard deviation, and we can punch those in. We're going to put in 0.9 for area, 400 for mean, and 15 for standard deviation. When we do all that, the calculator tells us that value of x is 419. 0.223, but IB always wants 3 significant figures, so 419. When you get that value, please take a second to make sure that makes sense. And in this case, like, hey, look, 419, it's bigger than 400. Well, like, we're in good shape. And it's interesting, if you had typed in an area of 0.1 here, it would have told you, oh yeah, it's like, 388, 381. And hopefully you'd realize, like, wait a minute, there's no way this can be 381. So hopefully you guys will be paying attention to that as you're doing these problems. Let's go to the next example. So you really should be able to do this problem. If you follow the last one, this should be really easy. Again, you've got this distribution. If you haven't already paused the video and done this on your own, please do it just to make sure you know how to push the buttons on the calculator. And I don't mean that in an offensive way, just make sure you give it a shot, right? The top 7% of children, so these people up here are the MTMs at 0.07. So we mentioned that the area less than that is 0.93. So we punch that stuff into the calculator. Let's see what we get. Yeah, so I got this x value here to be 45.3 minutes. And there it is. So in a basic sense, this is how we use the inverse normal distribution. As I was making this video, I came up with one other example for sort of a challenge question. I haven't seen this question before, but if you're interested in trying something, it's not crazy difficult, but it just ties together a couple things. So if you're interested, stick around. So here's this other problem. I don't know that I've ever seen this question on an IB exam, but it definitely feels like it's askable, so I figured we'd take a look at it. So a set of data is normally distributed with a mean of 50 and a standard deviation of 10. So I mentioned before, as soon as you see the words normally distributed, you should be drawing a bell curve. So here's my bell curve. Here's my mean of 50 with my standard deviation of 10. Now, I'm going to walk you through part A. If you want to pause the video and figure it out yourself, that's fine, but we'll talk about that one, and then I'm hoping you guys can tackle B on your own. So for A, find the median in Q1. So what is the median? The median is supposed to be the middle value. In other words, the median is supposed to be the number where exactly half of the data is below that and exactly half the data is above that. So if you haven't already thought about this and figured it out, what is the median of this data? What is the value where half your data is lower than that, half is higher than that? Well, in this case it's 50. Right? In the case of the normal distribution, the mean and the median are actually the same. They're both sort of the middle value. Okay? Now what about Q1? Right? What is Q1? Q1 is supposed to be the value that's sort of the median of the medians. Right? In other words, Q1 is the value right here where 25% is below that, and I mean, I guess 25 is between that median and, between Q1 and the median. Alright, so now that I've said that, you guys should have all the information you need to find Q1. So pause the video, use your calculator, see if you can figure out what that is. Okay, so for finding Q1, I went in and I used INV norm. I put in that the area was 0.25, because that is the area to the left of Q1, and that's what I needed. I put in that the mean was 50, the standard deviation was 10. It came back and told me that that first quartile value was 43.3. Okay, so that's my answer to part A. Now part B says find the interquartile range of this data. Now the thing that I have to sort of test you on is, do you remember how to find interquartile range? Right? How do we find interquartile range? Hopefully you remember that interquartile range is found by taking Q3 and subtracting Q1. Right? So that basically means we're going to need to figure out what Q3 is. So before you do that on your calculator, store that value you just got. Store your Q1 value, because we're going to need it later. So store that thing, and then pause the video, think about how you're going to find Q3, and go ahead and compute that. So Q3 is the guy that's up here, and the idea on Q3 is that 0.25 is above it, and 0.25 is between here and here. So hopefully you figured that out, this out on your own. For Q3, what is the area that we're interested in? Well, for Q3, the area to the left of it is 0.75. So if I'm going to be computing Q3, I'm going to have to use an area of 0.75. So when we punch that into the calculator, let's see what we get. So I ended up finding out that Q3 is 56.7. By the way, not to go off on tangents and things here, but I will mention, you'll notice that this number, 56.7 and 43.3, should be symmetric. They should both be the same distance away from the median. At any rate, to compute the IQR, the interquartile range, I just have to do 56.7 minus 43.3. On my calculator, I'm actually going to use the stored values, so I get a very precise answer. I end up with 13.5, and that's your interquartile range. Technically, the answer was 13.489. IB is willing to accept truncated answers, so 13.4 would also have been acceptable, but 13.5 I think is sort of a more accurate answer. So there's your interquartile range. So, the IB exam definitely does weird things for these problems, and having gone through these 3 videos, I feel like you guys have what you need, like I said, to tackle 70-80% of the questions. The other 20% are going to be things like this, things where you have to use other knowledge to put things together. There are some more complicated problems. If I get some time, I'll make some videos for those as well.